Yo, what's up everyone? Welcome back, Patrick here. And in this video, what we gotta do, we gotta find the limit as x approaches 3 from the positive side of f of x for each of these scenarios here. So notice we got 3 different limit expressions. And this is a very popular question. I've seen it come up on midterms in previous terms. I've seen it come up on assignments. And so thought I would make a video to it. And what I've seen so far that students have asked about is stuff in this kind of format. It's a little more simple than these ones, but thought I would include these two as well, just in case profs maybe take it to the next level this term and decide to throw more complex stuff on the midterm. You never know. So thought I would include some more complex questions as well. And this is going to be kind of tough to explain. It's going to be a little tough for me as well. So I'm going to do my best, but you may have to watch this video a couple of times for it to really sink in for what I'm about to go over. But let's go through it one by one. So starting with this, we got the limit as x approaches 3 from the positive side of f of x, some kind of function here, we don't know what it is, minus 5 over x minus 3, and then that limit has to equal 3. And so to break this down first, what I'm going to do is let's forget about this numerator for now. I'm just going to focus on this denominator and I'm going to do different cases. So the first thing I'm going to introduce is some kind of constant c. And let's say that this c here, it could be any number other than 0. Right? Some kind of constant other than 0. And so if we write, for this case here, if we rewrite this limit as x approaches 3 from the positive side of that constant over x minus 3, like that. What's going to happen over here? Well, notice as we approach 3 from the positive side, we're going to have like, let's say 3.0001 minus 3, which is going to give us a very small positive number. And so what we're going to have is some kind of constant up here, other than 0, over a very, very small positive number. So depending on if this constant is positive or negative, it's going to approach plus or minus infinity. This limit would, right? If this constant is something other than 0. And so you could plug in any constant. Let's say that we had like 2 over x minus 3. Well, how would this graph look like? Well, it's just the reciprocal function shifted over by 3. There's going to be a vertical asymptote there. So this graph, it basically looks like this. And so notice as we're approaching 3 from the positive side, the y values are going towards positive infinity. Or if we had a negative 2 over x minus 3, it would just be this graph, but reflected in the x-axis. So at this x value of 3, we would have what? This and this. So as we approach 3 from the positive side in this case, notice the y values would go towards negative infinity, right? And that would work for any constant you plug in here other than 0. So if you had 1, negative 1, if you had 100, if you had 1,000, negative 1,000,000, whatever it is, the limit as x approaches 3 from the positive side, it's always going to be plus or minus infinity if there's a constant up here other than 0. And so relating back to here, notice that none of these limits are approaching plus or minus infinity. And so what we know from that explanation that I just gave you is that this numerator here, it can't be a constant other than 0. It actually has to end up being 0. Right? So again, let's try a different example, but I'm going to come back to this in a second. But let's say we had the limit as x approaches 3, let's say from the positive side, keep it consistent. And let's say I had x squared minus 9 over x minus 3. Okay, what's going to happen here? Well, notice if I plug in 3, I would be in indeterminate form. Notice I would have 0 over 0, like that. Right? So we can't tell from this what the limit is approaching because we have a 0 on the top as well. And so if we actually work this through, notice we could factor this right? And then notice the x minus 3's are going to cancel out. And so if we plug in 3 for here, notice we're going to end up getting 6. And so notice that in this case, because it was in this format, it wasn't a constant over a very small number or over 0. It was 0 over 0. The limit actually ended up approaching a number here after we worked it through. Okay, and so what that means is that for you to approach an actual number like we're approaching here, this limit, if you do a direct substitution, it has to be in this indeterminate form. Right? When you initially plug in this 3, it has to be in that 0 over 0 form for the limit to approach an actual number. And so that's another point I want to make, is that this number here, it's actually irrelevant. This could be anything. This could be a 10. This could have been a 2. Could be any number that it's approaching. All that matters is that because it's approaching a certain number, that original limit has to be in indeterminate form for you to have a chance for you to get to a certain number, right? Because if you don't have 0 over 0, if you have a constant over 0, right? If this ends up being a constant over 3 minus 3, then this is going to go towards plus or minus infinity, right? So hopefully that made sense. Again, it's kind of tough to explain, trying my best here. But the point of all of this is that whenever you see something like this, basically you know that if you do a direct substitution initially, it's got to be 0 over 0. And notice that if we do a direct substitution in the denominator, we could tell 3 minus 3 is going to be 0. And so what that means is that the limit as x approaches 3 from the positive side of f of x minus 5, this has to equal 0. The limit of that numerator has to equal 0 as well. And so by the properties of limits, the limit as x approaches 3 from the positive side of f of x minus the limit as x approaches 3 from the positive side of 5 has to equal 0. Right, sort of distributed, quote unquote, that limit to both of these. And then the limit as x approaches anything of a constant, it's just equal to that constant. And so if we isolate for this, if we bring the negative 5 over, it's basically going to equal positive 5. Right, and so that is the answer for the first scenario. And notice again, we didn't use this 3 at all in any of this work here, right? We just knew that it was a constant, right? Could be any constant here. So we know that this has to be in that 0 over 0 format, right? So that is the answer for number 1. Right? And so knowing all that, whenever you get questions like this, you can kind of go through them a little quicker now, even if you get something complex like this. So notice with number 2, we got this limit. It's approaching a constant. If we do a direct substitution, if we plug in 3, notice the denominator is going to be 0, right? And so if we have a denominator of 0 with a direct substitution initially, for this limit to approach a constant, we know that the numerator has to be approaching 0 as well initially. Right? It's got to be in indeterminate form, because if it's not approaching 0, if it's a different constant, a constant over 0 is going to be plus or minus infinity. So we know that if we do the properties of limits, the limit as x approaches 3 from the positive side of f of x minus x squared plus x has to equal 0. Okay, and so doing a substitution, or properties of limits here, we'll have the limit as x approaches 3 from the positive side of f of x minus the limit as x approaches 3 from the positive side of x squared. Notice we could just sub in there the 3, that would end up being 9. And then the limit as x approaches 3 from the positive side of x, that would end up just being 3. And that would be 0. And so if we isolate for this expression here, bring the negative 9 over, it's positive 9 minus 3. That gives us 6. Right? So that there the limit of x approaching 3 from the positive side of f of x has to equal 6 for this scenario here. Because if it's approaching 6, we'll have 6 minus 3 squared, which is negative 3, right? 6 minus 9 is negative 3, plus 3 would give us 0. We would have 0 over 0, and so this limit can approach a constant then. Right? So that's the answer for the second scenario. And then for the third scenario, this one's a little bit more complex. First off, notice if we do a direct substitution, 3 squared minus 3 is 6, minus 6 is 0. And this whole limit is approaching a constant. We know the denominator is going to be 0 with a direct substitution, which means that with a direct substitution, the numerator should be 0 as well, or the limit as x approaches 3 from the positive side of the numerator should be 0. It's got to be in that indeterminate form for it to approach a constant. So basically what we can say here is the limit as x approaches 3 from the positive side of the square root of f of x minus e to the x has to equal 0 as well. Right? And so from here, what we can do, I'm going to show this one with more steps. Limit as x approaches 3 from the positive side of the square root of f of x minus the limit as x approaches 3 from the positive side of e to the x has to equal 0. So if this is a multiple choice question, you don't have to go through these steps. You should just be able to quickly do it. But in case that maybe this is a short answer question, they want you to show the work, this is how you would show the work properly with the properties of limits. And so the next step here is we would do properties of limits on this. So we'd have the square root of the limit as x approaches 3 from the positive side of f of x minus, notice that e to the x is continuous at an x value 3, so we could just directly sub in 3 here. That's going to equal 0. So we would have, sorry, this is bad format, my bad. Shouldn't have 2 equal signs here. Right, so we got this so far, and then what we're going to do is we got to isolate for this. Remember, we need an expression for that. So this would be the square root of the limit as x approaches 3 from the positive side of f of x equals e to the 3. And then to isolate for that expression, we could just square both sides. And so the limit as x approaches 3 from the positive side of f of x would end up equaling e to the power of 6. So that would be the answer to number 3. Right? So this one's a little bit more complex because we got the square root, we got this e, but nevertheless, that's what the final answer would be. Right? So this is kind of intense, like the way I showed the work is kind of intense. Again, on a midterm, you're not going to have to do this. I'm just kind of showing you just so you really understand what's going on. But if it's a short answer question, you may have to do these steps as well. And so just in conclusion, if you're running into stuff like this, where you got this limit expression, that denominator, if you do a direct substitution, ends up being 0. And then the whole limit is approaching a certain constant, right? We got 3 pi, e to the pi, all of those are constants. And again, the constant is irrelevant. These could have been anything. This could have been 10, this could have been 1,000,000, right? Notice how we didn't use any of these constants in any of the work. So as long as it's some kind of constant, that denominator is 0, then you know the limit of the numerator has to be 0 as well. And then from there, you got to figure out what this expression is going to end up being. And these could be like infinitely complex. So you got to be able to adjust. And another thing is that these f of x's, they could have also been in the denominator. So these could have all been flipped, right? So direct substitution, numerator being 0. Then if those f of x's were in the denominator, you would just do the same steps. The limit, that same limit of the denominator would have to equal 0, and you'd have to do that same algebra. They can maybe ask you like something even more intense. So they might ask you to find, let's say, 3 times the limit as x approaches 3 from the positive side of f of x minus 10, for example. right? Same steps would apply. You would have to find this expression. So we know for number 1, the limit as x approaches 3 from the positive side of f of x was 5. Right, it has to equal 5. That's what we got for the first scenario. And then you would just plug in 5 here. So you'd have 3 times 5, which is 15, minus 10, which ends up being 5 as well. Right, so anyway, I'm just kind of like thinking of different ways they can ask these kinds of questions, make it infinitely more complex. But yeah, this is basically how you do it. Hopefully that explanation made sense. It was kind of intense. You may have to go through it again. But again, if the limits are approaching a constant, and the numerator or denominator is 0, then the other side, the other corresponding numerator or denominator has to be 0 as well. It has to be in that indeterminate form in order for that limit to approach a constant.